All right, in the last section of chapter 2, we're looking at absolute value functions. So basically, we're just going to look at absolute value equations and how the graphs of the absolute value functions look like. All right, so the graph of the absolute value function. So the absolute value function is denoted like this: f of x equals absolute value of x. So these vertical bars means absolute value. The graph of it is vertical shape, so it's like a V shape, not vertical shape. And basically, it's formed of two lines. So if you look at absolute value of x on this side, so if you look from negative infinity to 0, you see that it's this line, negative x, which is just a line with slope -1 and y-intercept 0. And then from x greater than or equal to 0, it's the line y equals x, which is just a line with slope 1 and y-intercept 0. Okay, so keeping this in mind, when I ask what is absolute value of 3, you all be like, it's 3. When I say absolute value of -3, you'll also tell me 3, but what you're actually doing, absolute value of -3, is the opposite. It's negative x, where my x is 3. Okay? So, let's look at graphing absolute value functions. So if I have the function just f of x equals -2x plus 4, this is just a linear function with slope -2 and y-intercept 4. But what if I want the graph of absolute value of f of x, which is absolute value of -2x plus 4? It's going to be V-shaped, but it's not exactly like this one, right? Because it's not just absolute value of x. It is absolute value of -2x plus 4. So we're going to look into how to get the graph of absolute value of f of x when I know the graph of f of x. So we know how to graph a line with slope -2 and y-intercept 4. So this is the graph of the line. F of x equals -2x plus 4. The y-intercept is 4, and then the slope is -2. So if you have the graph of f of x, how do I get the graph of absolute value of f of x? Well, basically, you look at the portion of the graph that is below the x-axis. So this is below x, this is the x-axis, and below the x-axis is going to be this portion, right? And you reflect this by the y-axis. So you flip this portion by the y-axis, so it's going to end up going there. And then the result is basically going to be the graph of the absolute value function for that function, f of x equals -2x plus 4. So you notice we took this portion and we flipped it and we got this V shape, and that is the graph of -2x plus 4, absolute value of -2x plus 4. So if you have f of x, the graph of absolute value of f of x, you just flip the portion underneath the x-axis, you flip it over the x-axis, and that will give you the graph. All right, so to solve absolute value equations, basically it's going to come down to the fact that absolute value, for example, absolute value of x equals 3, that means that x can be either 3 or x can be -3, right? Because absolute value of -3 is also 3. So both of these x's satisfy the absolute value equation. So in general, if you have that absolute value of x equals to k, for k a positive number, then the solution is going to be x is either positive or -k. So in our case, we had that x equals plus or minus 3. All right, what if I want to solve something like this? Absolute value of x plus b equals k. Well, for example, absolute value of 2x plus 5 equals 2. Basically, is going to come down to solving two linear equations. So 2x plus 5, absolute value of 2x plus 5 equals 2 if 2x plus 5 is 2 or 2x plus 5 is -2, because absolute value of -2 is also 2. Okay, so if we solve this, so subtract 5 from both sides, we will get 2x equals -3. So then x equals -3/2 or -1.5. And then if we solve this other one, we get that 2x equals -7 So x equals negative 7/2, which is negative 3.5. So we got the two answer, x equals negative 3.5 and x equals negative 1.5. Okay, so this is how we solve absolute value equations. We can also see this visually by using our calculator. So what we're going to do, we're going to graph two functions. We're going to graph the function absolute value of 2x plus 5, and then we're going to graph the function y equals 2, which is just a constant function, the horizontal line going through 2. So if we bring our calculator, we have it solved in here, but we can do it and double check. So I'm going to go to y, and I'm going to do 2x plus 5. Let me clear that, and then so to get to absolute value of 2x plus 5, I have to go to math, num, and then pick ABS for absolute value. And I'm going to put 2x plus 5 in there and get out of the absolute value. So and then for y2, I'm going to put y equals 2. And then I'm going to graph it. And basically the solution, it's going to be where they intersect. So I have two solutions. The absolute value function equals to where they intersect. So I'm going to find the intersection points. So if it's not really clear from the graph, looking at it, where the intersection points are, we can use this command. So we go to second, trace to get to calc, and then we're going to pick intersect, number 5. So you see how that flashing point is on the absolute value? That's where we want it. And then the second time after you hit enter, you want it on the horizontal line. And then you hit enter again, and it tells you that this intersection point is at negative 1.5 for the x. So that's one of our solutions that we got doing it algebraically. And then to get the other intersection point, we do it again. Second, trace to get to calc. And then we go to intersect. And we want to go all the way to the left until we are on the absolute value one above it. And then we pick the horizontal line. And then again, enter. And we get the other intersection point, negative 3.5. So we can solve these absolute value equations algebraically or graphically.